Hello everyone. Today I'm going to talk about my operating system final research project, which is Network File System or NFS. Please enjoy my presentation. For introduction, we will cover about the history of NFS, application and implementation of NFS, mount protocol, NFS protocol, performance, versions, and conclusion. Let's start with the history of network file system. On the early days of Internet, Telnet's Remote Access Protocol and File Transfer Protocol or FTP are the earliest version of Network File Protocol. Telnet's Remote Access Protocol allows user to log into another host computer. The login user is given permission to access all the resources on that computer. FTP, on the other hand, is the most widely known application protocol in TCP/IP suite. It allows file transfer, directory navigation, editing, copying, and deletion of files between two devices that use the TCP service. The downside of these two protocols are that it's hard to set up and cumbersome for new user, which is the reason NFS is created. NFS was created by Sun Microsystem on 1984. Sun Microsystem is one of the leading developers of Unix. NFS managed to improve upon both Telnet's Remote Access Protocol and FTP functionalities. NFS allows easy file access over local and wide area network, and file access using NFS is as easy as local file access on your computer. Let's talk about the applications and implementations of NFS. NFS mainly manages the authentication and authorization of client and shared data. NFS connects the client and the server with the mount protocol, and the server needs to implement the NFS daemon first. After client administration is finished, the server will authenticate the user to determine which files can be made available. We talked about the mount protocol before. Mounting is the process of connecting the client and the server. The process of mounting are: first, the client creates a request for the mount port number from the NFS server. If acquired, the client will use that port number to ping the server, and if the server receives the ping, the connection has been established. Next, the client needs to get the file handle from the server through a mount request. If returned, the file handle's designated file system will be used by the client to ask for the file access to the server. If the access is granted, the files can be accessed by the client. NFS uses remote procedural calls RPCs to establish flow of request response within the client and the server. RPC is used to carry method calls and operation of NFS while mount protocol manages the connection. Let's talk about performance of NFS. NFS uses User Datagram Protocol or UDP for transportation in TCP/IP, making the server stateless. Stateless means that the protocol does not keep track of which files the clients have or have not accessed, improving the performance. Requests are independent of each other, and corruption will not occur when the requests are lost. The simple procedure will make the recovery process when the crash occurred fast and graceful. Let's talk about all versions of NFS starting from the earliest one to the latest one. Let's start with version 2, which is created on 1989. Version 2 is the most common version of NFS. It introduces UDP, limit file offset to 32-bit, and have accessible file size limit of 4.2 GB and data transfer of 8 KB, and NFS commits data to NVRAM before sending response. But nowadays, this version is obsolete. Version 3 have file offset extended to 64-bit, support bigger read and write transfer, enable use of wide area network, enhancing the transfer capabilities, and supports both UDP and TCP. Version 4 enforces the authentication and advanced caching. It has better file sharing supports for Microsoft Word, and mounting process can be done simultaneously using directory tree structure. It also improves performance using compound RPCs. Version 4.1 standardized the parallel NFS or PNFS, increasing its scalability. NFS can be used on global wide area networks and added UTF-8 support for file names, directories, and other identifiers. The latest version, which is 4.2, implements modern scale-out storage architecture. It adds server-side copy or SSC and adds application input-output advice. It has space reservation system that ensures available storage file. Support application data block AD or ADB that defines file format and support for security enhanced Linux or Linux. We reached the conclusion of NFS. The pros are NFS has achieved the ideal low-cost, user-friendly file sharing system that matches local file access. NFS also has centralized management that scales software and disk space. But the cons are that NFS is vulnerable to internet threats. So we need to be careful when using NFS, but it's okay if you use the network that use firewall. NFS will slow down its performance when the network is busy. However, NFS accessibility and smooth execution has earned it as one of the most used network file sharing system of all time. That is all for my presentation. Thank you very much for listening.